Whenever you look up and see those white contrails crisscrossing the blue, have you ever just stopped and wondered, how does all that work? I mean, you've got thousands of huge metal tubes flying around at incredible speeds. How is it not just total, absolute chaos up there? Well, it all comes down to this incredible, invisible system, a global rulebook that governs every single moment of a flight. And today, we're going to decode it. Just think about that number for a second. Over 100,000 flights every single day. That's more than one flight taking off every second, all day, all night. So how is this massive, complex dance coordinated? Well, the answer isn't luck. It's a really meticulous set of procedures that starts way before the engines even think about roaring to life. Okay, let's get into it. So the very first rule of the sky is pretty simple. Nothing is left to chance. Every single journey, whether it's a quick hop between cities or a long haul across the ocean, it all begins with one foundational document. And that document is called a flight plan. You can almost think of it as the trip's DNA, or maybe its blueprint. It's the formal way a pilot tells air traffic services, hey, here's what I'm planning to do. And for any controlled flight, filing one is absolutely non-negotiable. And this is the part that really amazed me. The level of detail they need. This is so much more than just, I'm flying from A to B. The plan has to have everything. The plane's specific ID, the exact route or airway it's going to follow, the intended speed, the altitude, all the way down to how many hours of fuel it's carrying and the exact number of people on board. So, here's the crucial part. This document has to be filed at least an hour before departure. And it's not just for air traffic control. If, God forbid, a flight goes missing, this plan is the first and most critical piece of info for search and rescue teams. It even helps the military know who's flying where so they don't misidentify a commercial airliner. So yeah, that one document is a lifeline, a safety tool, and a flight coordinator all rolled into one. It's the bedrock of safety before the plane even pushes back from the gate. All right, so the plan is filed, doors are closed, and the plane starts to move. But even on the ground, moving at what seems like a crawl, there's this highly choreographed ballet happening on the tarmac. And you guessed it, it's governed by its own strict set of rules. It's a lot like the rules of the road for cars, actually. There's a clear hierarchy. If two planes are coming at each other head-on, they both turn to their right. If their paths are about to cross, the plane that has the other one on its right-hand side has to give way. And just like on the highway, if you're overtaking another plane, the one being passed has the right of way. Simple, right? But it's totally collision-proof. Okay, now this is something I thought was just fascinating. What happens if the radio fails? The main way everyone talks to each other. Well, they go back to something that's a century old, light signals from the tower. And just look at this. The meaning of a simple color is incredible. A steady green light on the ground means you're cleared for takeoff. But in the air, it means you're cleared to land. A steady red on the ground, stop, right now. In the air, give way to other traffic and just keep circling. It's this vital, silent language that everyone has to know. So clearance is received, and the plane finally takes to the air. It's now entering a much more complex world, the invisible highway system in the sky. And this is where that partnership between the pilot and air traffic control becomes absolutely critical. Communication up there is all about one thing, absolute certainty. When a controller gives an instruction, a heading, an altitude, whatever, the pilot has to repeat it back, word for word. This readback isn't just being polite, it's a mandatory check. It makes sure there's zero misunderstanding, because a single wrong number up there could be catastrophic. Once they're on their assigned route, pilots are expected to fly with unbelievable precision, right down the center line of their invisible lane in the sky. But things like turbulence or weather can push them off course. So what happens then? Well, the rules are just as strict. And this chart just shows you how tight the tolerances are. If the plane's speed changes by more than 5% of what was in the flight plan, the pilots have to report it. If their estimated arrival time at the next checkpoint changes by just 3 minutes, they have to report it. That's how closely everything is monitored. And if they drift off track, they have to immediately get back on that center line and tell ATC. But of course, things don't always go perfectly. The system isn't just designed for perfect flights. It's designed for when things go seriously wrong. And as you can imagine, the procedures for emergencies are some of the most important rules of all. Let's go back to that radio failure idea, but this time you're in the air. The procedure completely changes depending on the weather. If the pilot can see the ground, that's called visual meteorological conditions, or VMC, the rule is simple. Just land at the nearest suitable airport.
But if they're flying inside a cloud, or IMC, a much more detailed plan kicks in. They have to hold their last assigned speed and altitude for a specific time, then go back to their original filed flight plan. All of this while flying completely blind to the outside world, just trusting that the system will keep everyone else away from them.
I'm sure you've heard Mayday in the movies, but there's another crucial call you might not know, pan-pan. And the difference between them is literally a matter of life and death. Mayday, mayday, mayday is for full-on distress. It means the aircraft is in grave and imminent danger, like an engine fire, and it needs immediate help. Pan-pan, 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 on the other hand, is for urgency. It's a situation that's serious, like a medical issue on board, but it doesn't pose an immediate threat to the plane itself. Now, in the extremely rare event that a commercial plane has to be intercepted by military jets, maybe because they lost communication or went way off course, there is a crystal clear life-saving protocol. The pilot's #1 job is to do exactly what the military jet tells them to do, immediately. Then they try to notify ATC, get on the universal emergency frequency, and set their transponder to the emergency code. And that brings us to these silent, almost secret codes. A pilot can tell the world exactly what's wrong without saying a single word. They just dial a 4-digit code into their transponder. 7700 signals a general emergency. 7600 lets ATC know their radio is out. And then there's the most chilling one, 7500. It silently tells every controller on the ground that the aircraft has been hijacked. So after navigating all of these potential challenges, the aircraft is finally on approach to its destination. But the system's job isn't over yet, not until the plane is safely parked at the gate and one last critical task is completed. It sounds like just another piece of paperwork, right? But this final step, closing the flight plan, is one of the most important safety nets in the whole system. The pilot has to formally tell air traffic services, "We've arrived safely, our flight is over." And here's why that's so important. If a flight plan doesn't get closed, the system automatically assumes the aircraft is still in the air and is now missing. It triggers an alert. And as this quote from the regulations makes very clear, forgetting this one simple step can launch massive, incredibly expensive search and rescue operations, all for a plane that's already parked safely at the gate. So, as you can see, the incredible safety of air travel is no accident. It's the result of this meticulously designed system with layers upon layers of rules, procedures, and backups. It's basically a global agreement on how to share the sky safely. And really, it all comes down to this. One unified system, one global standard, one set of rules that every single pilot, controller, and airline in the world agrees to follow. And that's what keeps every flight tracked, managed, and safe. When you think about it, the real marvel of modern aviation isn't just the powerful jet engines. It's this invisible, internationally agreed-upon rulebook. That's the true engine of safety. It's the silent hero that makes flying the safest way for us to travel. But, this rulebook is always changing, always evolving. And now, as artificial intelligence and more automation start taking on bigger roles in the cockpit, it leaves us with a really critical question for the future. Who, or maybe what, will be trusted to write the next chapter of the rules for the sky?